In this example, we're asked to work out the approximate value of the integral from 0 to pi on 6 of sine of x cubed. Now this is an expression, sine of x cubed, that you do not have a rule that you can anti-differentiate by hand. That means this must all be done on your calculator. There's two ways in which we could have done this. Method number one, just enter in the integral between 0 and pi on 6 of the sine of x cubed dx. Press enter and your calculator gives you your answer of 0.018765. Another way of doing this, which is what I've called method 2, is to enter in the function into our graph and plot the graph of sine of x cubed. Next step, would go to the menu and select Analyze Graph and then Integral. What we would then do is it will bring up lower bounds. The lower bounds was 0, so we would type in 0. And it would ask the upper bound, type in pi on 6, and you will see it shades in the area in grey and writes down the value. You'll see the value here is 0.019 compared to the answer that we got when we used the integral in method 1, which was 0.018765. They are the same thing if you have them to 3 decimal places. In this part of the question, we're asked to work out the integral from 0 to x of sine of t cubed. And we're told that x is between minus pi on 6 and pi. So the way in which we would do this, we would enter in the formula in terms of x into our calculator. So you could see that I've entered into f1x sine of x cubed. We would then go to menu and we would go into the integrals again, and from the integrals, when we're analyzing our graph, we would enter in a lower value of minus pi on 6, and we would then have to put in the upper bound, and the upper bound would be pi. You can see the calculator screen has shaded in those areas for us, and they've added them together to give us a value of 0.397.